Welcome back to the channel. Today, we'll be discussing naive Bayes classification, an efficient and widely used algorithm for supervised learning. This video will walk you through its concepts, applications, and a Python implementation to help you get started. Here's what we'll cover in this presentation. First, we'll define what naive Bayes classification is and explore its purpose. Then, we'll calculate conditional probabilities and likelihoods. Next, we'll learn how naive Bayes is applied to text classification tasks and understand the importance of Laplace smoothing. We'll also discuss its advantages, disadvantages, and the assumptions behind it. Finally, we'll implement naive Bayes using Python with scikit-learn. By the end, you'll have a solid understanding of this algorithm and how to apply it effectively. Naive Bayes is a supervised learning classifier based on Bayes' theorem. It calculates the probability of a class given the data by reversing the conditional probability. This algorithm is commonly used for tasks like spam detection, author identification, or sentiment analysis. Its simplicity lies in the assumption that features are independent, which, while not always realistic, makes computation fast and efficient. Conditional probabilities and likelihoods are at the heart of naive Bayes. The formula for Bayes' theorem calculates the probability of a class given the data by multiplying the likelihood of the data given the class by the class's prior probability, divided by the overall probability of the data. For text classification tasks, these probabilities are estimated based on the frequency of words in labeled data. Naive Bayes is particularly effective for text classification. For instance, imagine classifying tweets based on their authors, such as distinguishing between VIP and staff tweets. The algorithm calculates word frequencies for each class, multiplies the probabilities of each word in a new instance, and assigns the class with the highest likelihood. This process is straightforward yet powerful for handling high-dimensional text data. One key enhancement to naive Bayes is Laplace smoothing, which prevents zero probabilities for words that don't appear in the training data. By adding a small constant, such as 1, to all word counts, we ensure that no class is ruled out entirely because of missing features. For example, if the word love is rare in the dataset, smoothing adjusts its probability to prevent skewed predictions. Naive Bayes has its pros and cons. On the plus side, it works well with high-dimensional data, is efficient and fast, and handles categorical and missing data effectively. However, it assumes feature independence, which may not always reflect reality, requires large datasets for accurate probability estimation, and needs pre-processing for continuous data. To implement naive Bayes in Python, you can use scikit-learn's multinomial NB. First, pre-process the text using count vectorizer to convert words into numerical features. Then, train the model with labeled data and use it to make predictions on new text. Scikit-learn simplifies this process, allowing you to focus on the results. To summarize, naive Bayes classification uses Bayes' theorem to predict class probabilities efficiently. It's ideal for text classification tasks and can handle missing features using Laplace smoothing, while it assumes feature independence. Its simplicity and speed make it a valuable tool in data science. Python's scikit-learn provides an easy way to implement and experiment with naive Bayes models. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.